Welcome to Mr. Tompkins Ed Tech and my series of exam question compilation videos on key topics you might still be struggling with. This particular video covers similar shapes. I've taken related questions from my past paper walkthroughs and given them to you here back to back. This series is intended for the last few weeks of your revision, and my advice is to go through all the practice papers and past papers before you look at these, or the compilation videos will be the mathematical equivalent of endgame spoilers for you. Having already worked through all the practice papers, these compilation videos will give you a deep dive on topics you are still finding challenging, give you more of an overview, helping you recognise command words, identify key features and strategies, building your confidence and helping you apply these techniques for future papers. If you find it helpful, please give the video a thumbs up, it will really help me out. Also, if you haven't already subscribed to my channel, why not do that now? I'll be making lots of these compilations over the next couple of weeks and you'll get notified of these as soon as I upload them. Right, let's get into it. Question 2. Circle the reason why these triangles are congruent. Now we've got 4 different rules for congruency for triangles, and these are our 4 different answers we've got that we can ring here: side, 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 angle, side, angle, and right angle, hypotenuse, side. So you can see here we do have a right angle in both, but what we don't have is the hypotenuse. Instead, we've been given those 32-degree angles that match up and the included side, so that one and that one. So we've got 2 angles and an included side, so our reason for congruency is this one here, ASA, and not that one there. Question 10. Here are 4 triangles and we need to know which 2 triangles are congruent. Okay, now we have certain tests for congruency that we need to know for the exam. The first one, RHS, which is right angle hypotenuse side. Now these are non-right angle triangles, so that one isn't going to be the case. And the others are side, 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 angle, side, and angle, side, angle. Basically what we need to do is make sure we pair up these 3 things on 2 triangles to see if they are congruent or not. And the order that we pair them up is important. So when I wrote down side, angle, side, that's not the same thing as ASS. Not only is that a naughty word, it's also not going to get you the marks. So let's have a quick look at these diagrams. This one here is side, angle, side. So that's one of those. 5, 30, and 3. This one up here, A is not anything. I've got 2 sides, but this is not the included angle, so that isn't going to be congruent to anything. And again, this one down here, that isn't the right way around either. It has to be this one up here. Side, angle, side. So it's B and C that go together. Oops. Let's do that again. B and C. Circle the reason for your answer. It's side, angle, side. In question 14, we're given 2 chevrons and we're told that they are similar, and we need to work out this value down here, this x value. Okay, so we've got a pair of sides or lengths in the diagram that go together. So 8 and 12 are the equivalent sides on those 2 diagrams, so we can use those to find out what the scale factor is. So my scale factor is going to be 12 divided by 8, which is 1.5. So going from here to here is times by 1.5. So from here to here must also be times 1.5. So then x is going to be equal to 6 times 1.5, which is equal to 9. So my answer is 9. Question 22. PRT and QRS are similar triangles. And we're asked which of these is equivalent to QR over PR. Well, QR is QR, that's that line there, isn't it? and then PR is this line. So basically you're comparing two equivalent sides of two similar triangles. So sides are always going to be in the same ratio, so as long as you're going to match up the pairs of sides you're looking at, then they are going to have the same ratios as well. So let's have a look. So RS to ST. So remember that QR was the smaller one and PR was the larger one, wasn't it? So as long as we've got the smallest one on the top and the largest one on the bottom, and they're matching up, they should be good. So where's RS? RS is that one. RS to ST. Well, that isn't going to work because they aren't matching sides. ST is not a side of the triangle. So not RS to ST. What about QS to PT? Let's just get rid of those two. QS is that side to PT. Yeah, those two are matching. Small one to big one. So yes, that one is true. What about PT to QS? PT to QS, that would be big one over small one. That isn't going to be the same. And RT to RS. RT to RS. Again, that's big one over small one, so that one isn't going to work either. So it's just that first one, then QS to PT. Question 6. A and B are similar shapes. B is an enlargement of A with a scale factor of 1.5. Work out the values of X, H, and W. Okay, so first off, I've got X. Now that is the angle at the tip of my chevron. If two shapes are similar, then all the angles are going to be the same, so that's going to be just the same as 54, isn't it? So I'm going to say that X is equal to 54 degrees. Okay, now my 5 centimeter one matches up with my H, and our scale factor we're told is 1.5. So then H is going to be 5 times 1.5, which is 7.5 centimeters. Okay, and then finally, what have I got? I've got W here and 9 here. So if I timesed W by 1.5, I'd get 9. So then W is going to be 9 divided by 1.5, isn't it? So W equals 9 divided by 1.5. Okay, can you do that in your head? I can, but just in case you can't, let's just tap it into the calculator. 9 divided by 1.5 is 6. Okay, so I've got X is 54 degrees, H is 7.5 centimeters, and W is 6 centimeters. Okay, we've got a pilot of an aircraft and he wants to fly from A to D, but actually he's a little bit off course. So in fact he's flying from A to E instead. So the question is wanting to know how far off course he is. So we need to work out that distance DE. Now we can do that using similar triangles. We know that from here to here is 60 miles. So for every 60 miles, he's 1 mile off course. Okay, so by the time he's gone this distance, which is 60 plus 150, which is 210 miles, how far off course is he now? Okay, so we know in similar triangles that sides are always in the same ratio. So we know that side DE divided by 210 is going to be the same as the side BC, which is 1 over AB, which is 60.
In other words, DE is going to be 210 over 60, which is 21 over 6, or 3.5 miles. So 3.5 miles. So the next part of the question says, how should the aircraft have turned at C to fly directly towards D? So coming back to our diagram, basically the point C, it should have corrected its course and gone off in that direction there. So it needed to turn, it needed to turn this angle. Now that turn is clearly more than 1 degree, because that's 1 degree there, isn't it? So it's more than 1. It's just whether or not that this distance here is bigger than or smaller than 1. So we're saying that that's 1 degrees. This angle here is the same as that one. It's alternate to that one, if these two lines are parallel. Now, is this angle bigger or smaller than that one? Now, I would say because this distance here is shorter than this distance here, then this angle here must be smaller than 1. So this angle here must be smaller than 1. So the angle of turn must be between 1 and 2 degrees. So I'm going to go for that one there. Question 11 says that the area of a shape A is 36 centimeters squared and the shape B is similar to shape A with sides 4 times bigger. Circle the calculation to work out the area of the shape B. Okay, so if we've got two similar shapes and their sides are in a ratio of 1 to n, then their areas are going to be in the ratio of 1 to n squared. Now in this case, the scale factor of their sides is 4, so the scale factor of their areas is going to be 4 squared. So we're going to work out the area of the larger shape by multiplying through by a factor of 4 squared. It's that one there. Okay, question 18. Here are two similar solids, A and B. If they're similar, it means their sides are in the same ratio. And we're told that the volume of B is 400. So this one has a volume of 400. Is the volume of A approximately 1/4 of the volume of B? You must show your working. Okay, well, this side and this side match up. So we can work out the ratio of their lengths. So their lengths are in the ratio of 1 to 8 over 5, which is 1.6, 1 to 1.6. And then the ratio then of their volumes is going to be the cube of that. So what is 1 to the power of 1.6 cubed? So raising 1.6 to the power 3, I get 1 to 4.096. So roughly, I suppose we're approximating, aren't we? So is the volume of A approximately 1/4 of the volume of B? I would say it is. We've got their ratios of 1 to just over 4. So I would say that yes. A is approximately 1/4 of the volume of B. Question 17. A and B are similar solids. Solid A is of length L and solid B is of length 2L. Alex says the volume of B is double the volume of A because the length of B is double the volume of A. Is he correct? No, he's made a classic error there. That is not correct. Similar in mathematics has a particular meaning. It means one is an exact enlargement of the other. So if two shapes are in the ratio of 1 to n in terms of their length, this is 1 to 2, isn't it? These things have got a ratio of 1 to 2 for their lengths. Then for areas of similar shape, that is going to be 1 to 2 squared. In other words, it's going to be 1 to 4. And then their volumes is going to be 1 to 2 cubed, which is 1 to 8. So her volume should be 8 times bigger than the length. Well, the volume should be 8 times bigger. So let's give her a reason. The volume should be 2 cubed, or 8 times larger. Question 23. Solids X and Y are similar. X has a volume of 64 cubic centimeters, Y has a volume of 343 cubic centimeters. The surface area of X is 176. Work out the surface area of Y. Okay, so we've got two shapes, two lumps of undescribed size, of undescribed shape, sorry, and we know that one is similar and bigger than the other. So what's the scale factor? We need to find the scale factor, don't we? Now, there is a relationship between the scale factors of lengths, areas, and volumes. So basically, let's say the scale factor here is n, then the scale factor of lengths is n. So the scale factor of areas is going to be the square of that. It's going to be n squared, and the volumes then are going to be in the relationship of n cubed. Okay, so we've got the two volumes. We know that this one is 343 cubic centimeters, and we know that this one is 64 cubic centimeters. So if we divide one by the other, we shall find the scale factor of their volumes, which is a cube of the scale factor of their length. So we should then be able to use it to work out the scale factor of their areas. Okay, so n cubed then, the scale factor of their volumes, is going to be my big shape, 343, divided by my equal shape, 64. So then, I've just noticed they're cube numbers. So I can then work out n very easily then by cube rooting those two numbers. So what's the cube root then of 343 over 64? Well, cube root of 343, I do recognize it, do you? Personally, I think it's a good idea to learn by heart your first 10 cube numbers and square numbers. And then so when you're in an exam, it's very easy for you to do these sort of things. So cube root of 343 I already know is 7, because I know my cubes. And the cube root of 64 I also know is 4. So then the scale factor of their lengths is 7 over 4. So n squared is the scale factor of their areas, or even including surface area. Any two-dimensional area that is the same on both objects will be in this same ratio. So squaring 7 and 4, I'm going to get 49 over 16. So then that is the scale factor from the small surface area to the large surface area. Now we were given the small surface area. It was 176. So what we need to do then, surface area of y, surface area of y is going to be the surface area of x, which is 176, times by our area scale factor, which is 49 over 16. Okay, so grabbing the calculator, 176 times by 49 divide by 16. That comes out to be 539. Okay, so that's my answer, 539.
Well, I hope this video helped you get a better overview of the topic. If it did, give it a thumbs up. You can find more exam question compilations over here. For more past paper walkthroughs, click down here. If you want to visit my Amazon shop with my recommendations for calculators, revision guides and other maths related stuff, click down here. Good luck in your revision and in your exams, and see you again.